Hello everyone, welcome to Algo Eminence. The topic which I have brought for the students is actually for the final year students who are approaching the placements and they'll be sitting for their coding interviews. So here what we are trying to do is like suppose as I'm talking about coding interviews, you will be doing many of the questions or practicing on the online platforms like your Lead Code, Code Forces, HackerRank, HackerRun, and there are many more online platforms. So what maximum students do is they just randomly try to solve different type of questions, so that makes it actually messes up the things. They don't understand what, how, and what procedures they have to follow. So what we have done is we have brought some patterns and algorithms, so that if you study those patterns or you follow those algorithms, based on that you can do many similar type of questions just by simply changing one or two steps in the algorithms. But the thing is, there is some prerequisite that is required for this particular course. As I said, it is for the final years. So it is basically the prerequisite. What you require is your basic data structures knowledge. You should have good command in your arrays, linked lists, stacks, queues, trees, and graphs. You should have good knowledge of recursion, and then you should have a very good knowledge with the asymptotic notation. That is nothing but the to calculate or to find out the time complexity and the space complexity. Now, you very well know why you go for time complexity and space complexity, so that we can optimize our given problem statement. So, coming up to the course, what we are following is, this is about some different type of patterns, some 28, 29 patterns we have, which once you go with that, as I said, you can do many similar type of questions. It might be in any of the online platform. As I was talking about the patterns, now as you can see in the screens, we are having some patterns. What I will doing is, I'll be first giving you some brief idea about all the patterns, and then one by one we'll be dealing with patterns and we'll be doing some questions. Based on that, again I'll be telling you some similar questions which you can do in different online coding platforms, right? So, coming to the very first pattern that we have, that is two pointers. Now, as the name suggests, that you will be taking two pointers to solve any problem statement. Like some input has been given and you have to solve that, you have to go for your desired solution. What we do in this type of an algorithm is, we will be taking two pointers. What is important in this is the placement, where you have to place these pointers. In some questions, it will be like you are putting a pointer in the starting and the other at the end, and then you are traversing the data. In some cases, there will be like you are putting the pointers one by one next to the other, and you are traversing the data simultaneously with both the pointers. So it depends upon the problem statement how the pointers will be utilized. Next, what you see is a fast and slow pointer. Generally, fast and slow pointer algorithm is used for linked list, where you are traversing the whole linked list. Based upon this, you will be solving there are many actually questions in linked list which can be solved by fast and slow pointers. As the name suggests, one pointer will be slow and the another pointer will be fast. So, by the movement of the pointers, what you do is you get your desired result over there. Next, you have your sliding window. In sliding window, what we assume is, there is a window, a size of something will be given like 5 elements or 10 elements based upon your problem statement. There is a window and it is sliding. Generally, sliding window your algorithm is used in subarray type of a question, where all the data has to be taken sequentially. So what we assume is, suppose this is a window, what is happening is, it is sliding on the data. So the data from one end is getting out of the window, means you are not taking in process, and some of the data has been coming inside in this window. So this is the way how a sliding window algorithm works. Next, which you see is merge intervals. Merge intervals is actually a very good topic, where what we see is the data are overlapped. When you have some data, those are overlapped, and based on that you have to do some process so that you get your desired result, right? Generally, this is merge interval type of an algorithm is used in hotel bookings, scheduling of meetings, airlines, railways. They go for this type of merge interval type of an algorithms. Next, we come to cyclic sort. As the name is telling you that it is sorting, but it is not the sorting algorithms which you have studied. Cyclic sort works on a range type of an data, where the data is given in range. So when you use a cyclic sorting algorithm, the time complexity over here is big of n. Next pattern which you will be seeing is in place reversal of a linked list. By the name you can understand it is working on linked list, and in place suggests that you won't be taking any extra space in the memory. In place means that whatever changes in the data is done, it is done in the data. The in place name itself suggests that there is no extra memory being added. You are not taking any extra memory to store the data. Whatever memory is utilized by the input, in that only you are doing some changes so that you get your desired output. This is stacks. Stacks in general, everybody you have studied. What happens in stacks? Stack is nothing but last in and first out. It works on that policy. Based on that, there are many questions to be solved. You might have solved balanced parenthesis. We will be doing the questions again. There are questions of balanced parenthesis where you match up the parenthesis so that some arithmetic expressions can be solved. You see postfix function, you evaluate some postfix or prefix functions in that. So, for that we go for stacks. Actually, why I have put stack in here is to explain you what is monotonic stack. Monotonic stack is bit different from stack. As I said that stacks works on LIFO, like the data, as the data is being inserted, it will be pushed inside the stack, and based on that only the popping of the data will be, or the deletion of the data will be taken from the stack. But in monotonic stack what happens, it is using stack only, but the data is stored in increasing or decreasing manner the way your question demands. Next we see hash maps. Now hash maps is the data structure where the data is stored in a key value format. Actually it provides a very fast lookup time. Fast lookup time means if you have to retrieve some data, you have to see the placement of the data. What happens is you can go for hash maps. Next pattern which we see, the two patterns which we can see over here is tree breadth first search and the tree depth first search. We will be seeing BFS and DFS on tree, and we will be solving maximum questions in this. Next you have graphs which also works on the same format of DFS and BFS. Next you have island matrix traversal where you use the graph technique only, and you will be traversing in 4 adjacents so that you can get your desired output. We have a 2 heaps algorithm where you will be having 2 heaps in the form of a maximum or a minimum, and the data will be used in such a way that you get your optimal result in this. Similarly, you use subsets. Next you have your modified binary search. Searching algorithms everyone knows, you are having linear search, binary search. So, this is algorithm where you will be using a binary search only, but with some modifications in that, so that it will be useful to solve maximum questions. Next you go for bitwise XOR, that is nothing but bit masking. We will be seeing some top k elements, k-way merge. These are again a very good topic which you will be dealing. Next you have greedy algorithms, we go for dynamic programming, and you go for backtracking. So, backtracking, dynamic programming, for these topics you need recursion. I will be before starting backtracking, we will be having bit revision or recursion, and then we will be doing with backtracking, we will be going with dynamic programming. We have try, then we have topological sort which comes under graphs. Then what we have is we go for union, we go for ordered set, we have prefix sum, we have multi-thread, and we have some questions which apart from this patterns can be solved by its other manner. Apart from these 28 patterns, we have some miscellaneous questions also which are very important. I will be dealing with some string algorithms also, so that you can go for pattern recognition type of questions.